Hi guys, in this video we are going to take a look at computing the double integral that represents the volume of the solid line under the plane. So we've got a plane and it is negative 4x plus 6y plus z equals 100. Now, what does this rectangular region looks like? So generally speaking, when they give you this x and y intervals, so x is going to go from 3 to 5 and y is going to go from 1, 2, 3, 4, 5. So this is going to be what that rectangle is going to look like. So these are the vertices, and then I can just go ahead and join them with line segments. And this is what we are going to be integrating over. Now, generally speaking, what you need to know is that a double integral of a surface that's written in the format z equals f of xy will represent the volume if you integrate f of xy over whatever region, right? The region has to be the bottom and the surface f of xy has to be the top. So just to visualize the situation, I want to show you this thing on the CalcPlot 3D. I'm not sure that this is the best representation of it, but here's what I will do. So I'm going to go ahead and add a region. Now I need to define the 2D top. So the 2D top here, if you look at the graph of this rectangle, that's going to be y equals 5, and the bottom is going to be y equals 1. So that's what I will need to set here. So the top is going to be 5, and the bottom is going to be 1. And then x is going to change between 3 and 5. So that's going to be my rectangle, okay? And then I need to also change in, well, now you can see what's going on, right? You can see like the rectangle there. And then you can also see its 2D representation over here. But I have to also define the 3D top. And the 3D top right now is not what I want here. This is supposed to be a plane. So in order for me to visualize it, I have to represent it as z equals something. So if I have this equation, I need to solve that for z, okay? So solving it for z is going to be 100 minus 4x. So that's actually going to be plus 4x and minus 6y, right? So that's going to be the function that I will have to integrate. So let me see if I can define the slope. So this is 100 plus 4x minus 6y. Okay, so right now we can't really see it. And that's because I have to tinker with the scale. So for y, I actually want to go all the way to 100. So I'll start maybe at -5, go to 100, but I need to change the scale factor here. So I'll change this to 10, otherwise it looks really weird. So there's a different scale, but you can see the solid, right? So you can see that above it's bounded by that plane and below it's bounded by the rectangle, okay? So if you were to integrate this function f of xy, which is 100 plus 4x minus 6y, over this rectangle, you'll get the volume of that solid, right? So you can see clearly what the solid would look like. Okay, so let's start working on actually finding the volume. So the setup is going to be very easy here because all we got to do is integrate over this rectangle. So, and the function that we need to integrate is already given. So that would be 100 plus 4x minus 6y. And I'm going to set it up, obviously, as a type 1 region because it's always easier to do type 1 unless there is a reason. And here you have a rectangle anyway. So the outside limits, so this is very important, that the outside limits are going to be the x limits, right? So x will change from 3 to 5. That's going to be 3 to 5 over here. And then the y limits are the inside limits, right? Because I am doing dy dx in that order. So that will be from 1 to 5. So here it's going to go from 1 to 5. So let's see if we can find the volume of that solid. Okay, so first we're going to integrate it with respect to y. So 100 integrated with respect to y will just be 100y. Okay, and then 4x integrated with respect to y. So think of 4 and x both just numbers because this is just integration with respect to y. So a term that doesn't have y, you just multiply by y. So this is going to be 4xy. Okay, then 6y integrated with respect to y. So you should know that integral of y is y squared over 2. So this will become 3y squared. Okay, so when I substitute, it is very important that you write which variable you substituting for the inside the integral. So this would be y equals 1 to y equals 5, right? And then the dx is still outside. Okay, so now let's do some algebra here. Quickly substitute for y. So first we substitute in 5, which is going to give me 500. And then plus 4 times 5, that's 20x, minus 3 times 5 squared, well, that would be 75. Okay, so I substituted the 5. Now I'm going to subtract parentheses. Now I'm going to substitute 1. So this will be 100 plus 4x minus 3. Okay, so it's very important not to start integrating until you are completely sure that you simplified everything. So I'll go ahead and do that. So 500 minus 75, that's 425. And then plus 20x. Okay, and then over here, this is going to be right here, 97 plus 4x. So when I'm subtracting, this is going to be minus 97 minus 4x. So it's very important that that minus gets distributed to all terms. So again, I'm still not ready to integrate because I still have to collect like terms. So I can see that I have 20x minus 4x. So that should give me 16x. And then 425 minus 97. So think of it as 425 minus 100, which would be 325, but then there would be 3 more. So I think that would be 328. Okay, so hopefully that's right. Now at this point, once I simplified it, I can go ahead and integrate. So x integrated would be x squared over 2. So that will become 8x squared plus 328x. And I'm substituting 3, 5. Now at this point, you do not really have to do anything in your head because now you can just go to the calculator. So let me just check to make sure because I did some stuff in my head which I probably shouldn't have. Okay, so what's 425 minus 97? That is 328. Okay, so now I just have to plug in. So let me define f of x equals 8x squared plus 328x, and I want to compute at 5. So whatever I got, and then subtract, compute it at 3. And the difference will give me 784. So it's important also to note that if you get a negative answer here, that should not be good because you are computing the volume, and volume of any solid should be positive. So at least that part is good.